Hi everyone, this is a quick video to explain how the arithmetic shift left works in the Commodore 64. So if you look up C64 ASL, it'll come up with the wiki. So ASL arithmetic shift left. It's worth reading some of this stuff, but it can be quite complex at the same time without really knowing some of this stuff. So if we come to here, we do something simple like load the accumulator with 07, so just the number 7. So if we assemble and run, we can see 7 is stored in the accumulator. Then we're going to store that into 0200. So we're going to put that into that memory address here. So if we assemble and run, we can see 07 comes into that memory address, that byte there. Now, if we put ASL across that, we can't do the ASL across the accumulator. You do it across the memory address. So it's going to modify that memory address. So $0200. So we're going to arithmetic shift, that's hard to say, shift left on all those binary numbers. And so what does that actually mean? So if we come across the calculator, we put hex as 7. And so you can see 7 is 0, 1, 1, 1. That's what a binary is, and so it goes from right to left. So 1, and then the next bit means 2, and so on and so forth. The next one is 4, so 4 plus 2 plus 1 is 7. So then what's happening is ASL is actually shifting all of these across and putting a 0 at the left because it's arithmetic shift left. All the numbers go left. So what happens when we run this? Assemble and run, it becomes 0E. So coming across to our calculator, let's put 0E. Now you'll notice it's 1110. So it's actually added a blank bit in the byte. So it's 1110 rather than, if we go back to 7. So all those ones were on the left, the right-hand side. We've just moved those left by 1. So that's what ASL does. So if you think about it in Excel, for instance, we've got 0, 0, 0, 0, 1, 1, 1. That was 7. So that's our calculation for 7 in the bits and the byte. So then if we were to say arithmetic shift left of this, so this is 7, and once we run this function on it, it's going to say, okay, right, well, I'm going to put a 0 here, and everything else gets moved across. So it goes 1, 1, and then 1. And that's why it looks different. And so if you ran this again, it would become 1, 1, 1, and then 0 and 0. So that's doing the ASL again. So I got that right? Yeah. So it just keeps pushing it across, and these would be 0, 0, 0 like that. So if we come back to here and we run this again, and we go assemble and run, you'll see 1C. So if we come to our calculator and you put hex 1C, you'll see here it's now 3 zeros, 3 ones, and 2 zeros because we've now shifted it left twice. So let's check to see if our calculation here and here is the same. So 0, 0, 0, 0, 0, 0, 1, 1, 1, 0, 0. So that's pretty much how the ASL function works. Hope you find that useful. Certainly let me know in the comments. Cheers.